Okay, welcome to Fusion Homework Recap number 2. Well, Fusion Homework number 2 recap. That's what we're doing. So, we are going to create new, and then we are going to create a new sketch. We are going to do this on the front plane, as I am wont to do. And the first thing I'm going to do, the homework is to create the design as shown. I am going to just start with a general outline. So I'm going to create a line, and I'm going to go down, over, up, and then an arc between the two. And so that's the general shape of the outside, but what we're going to do is we are going to make that tangent, so we have the nice smooth line. And then we're going to go to, since this homework is parametric, we are going to change our parameters, and we are going to make, we only have one expression here, and that's x. Usually you want to comment. In this particular case, I know the design is only going to have the one. So I'm going to dimension this bottom line as x. Enter twice. And now we have this set to x, which is all fine and good. We are going to make the sides and the bottom equal. We are going to make the other side equal, just in case. And then while I'm here, I'm going to make this center part coincident with there. So now this is basically fully constrained. See the little lock right here? There's no place for this to go. Everything has been defined. But we have more to do. So, this assignment was a little bit of a puzzle. So, what we have, I'm going to hit C for circle. We have 3 circles that are supposed to be approximately here. That are supposed to be as the same size, oh, and a circle here. So, this circle is supposed to have the same dimension as the gap between here and here, as the gap between here and here, right? And so how do you create that situation? We know these all circles are supposed to be the same size. And so if this circle is one size, and this circle is one size, and this circle is one size, and that same size is the size of this gap here, and this gap here, and this gap here, and this gap here, you count that out, it is 1, 2, 3, 4, 5, 6, and 7 of the same size. What does that tell us? That tells us that this circle is, I'm going to hit D for dimension, and I'm going to click on the circle. I said circle, there we go, is x divided by 7. How did I get that? Well, this is x, and the full distance from here to here, there were 7 of the same thing. So we're dividing that by x. So what can we do? We can say that is equal to that. That is equal to that. And so we're on our way. So we're gonna need some construction lines. L for line, and I'm gonna go from the bottom to here. And while I'm here, I'm gonna go from here to here, and here to here. And then we're gonna close that off. And then what I'm gonna do is hit escape so that we are not selected to anything. And now I can select this line and press X to make it a construction line, a construction line, a construction line. There's a lot of different ways to do this. This is the way I saw is most efficient. I will not mark you down for doing it differently. That's just the way things will be. So here's the trick, though, is that I went to this center point. That's not the same size as the circle. This is from the edge of the circle to the bottom is supposed to be the same size as the circle. So if I measure from here to the center, that's actually 1.5 times the circle, which means, so if this is 1/7, and this is 1.5 times that, I can dimension with a D this line. Whoa, that's the angle. Escape. Dimension. I see. I have that selected. We have to make sure to deselect that. D for dimension. We're going to bring this out. And this is 1/7. So we're going to say X divided by 7. But we are doing 1.5 of those. So I'm going to put that in parentheses and multiply the whole thing times 1.5. Now, this is kind of a convoluted way to do it. But I'm kind of a convoluted guy. So you can do this however you like, but what this is doing is that this distance here, from here to here, should be the same as here to here. All right, so that gets the height the same as this here, but now we want the distance from here to here. Now notice that since we're going to the center of these circles, it's actually double the circle. So instead of 1.5, it's going to be this dimension, D for dimension, select that line, is going to be X divided by 7, which is the size of the circle. But then we're going to multiply that times 2. Was there another way I could make that? Sure. Instead of dividing by 7, I could have divided by 3.5. That works too. There's a lot of ways to go about this. You could also make just a whole pile of construction lines, but this is the way I'm doing it right now. So that's how I'm going to demonstrate it. I'm going to make this line equal to this line, so I don't have to do that again. And so now this gap should be the same as the size of the circle, which should be the same as this gap, which would be the same as this, same as this, same as this, same as this. Okay. And then the last thing we needed to do for this assignment was to make sure that this gap here was the same size as this circle and this gap here. Could I make a vertical line make it tangent to both of these? Sure. Or I could dimension the circle and say it is x times 5/7. Why 5/7? Well, we know we have one side here and we have one side here, so that's 2/7. So the radius, which is the full width of the circle, should be 5/7. So if I wanted to see if I did this right, I could make a line that goes from here to here, and I'll confirm that, and a line that goes from here to here, and confirm that. And I'm going to zoom in a little bit, and I'm going to add, oops, I'm going to create a, there it is, point. I'm going to put a point here, I'm going to put a point here, zoom out, we're going to do the same over here, point there. I'm going to zoom in a little bit, make sure that I'm snapping to the right place. Here, 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 and here. And then we'll do some dimensioning. So if we dimension from here to here, 0.714. Dimension here, oops, here to here, 0.714. Yes, we know that. Dimension here to here, 714. Yep. And so forth. You get the idea. Oh, so all of these things are the same. Here to here, and this distance here should all be the same. That's how you do it. Notice that my sketch is not fully constrained because I made these dumb little lines. I am going to, okay. So taking out all of the lines I was using to measure, you'll notice now my sketch is fully constrained. So that's where we were. We got that lock here. That means that everything is all set. And if I were to modify my parameters, I can say instead of 5 inches, I want that to be 10 inches. It should give me the same shape, just a different size. I want it to be 50 inches. There we go again. All right. Thank you very much.